Good evening, team. I can see today we are few. I don't know where the rest are, but we are going to proceed so that we can save on time. I hope they will be able to join as we proceed. So welcome to our today's session. Sorry for inconveniences today. I am to help Zandok and Tabitha to install the SPSS software so that they can be able to do the assignment. So that's the reason why I've delayed. But it's good all of us to be on the same page. So I hope that they will be able to do the assignment. Otherwise, I would welcome one of you to lead us with a round of prayer before I welcome Samuel to give his opening remarks. So can we have a volunteer to pray for us? A volunteer to unmute to pray for us? Or we will pray at the end. All right, then, because of time, we'll have a closing word of prayer. So allow me to welcome Samuel to welcome you to this call and also give his opening remarks as we start our today's session. So Samuel, if you can hear my voice, please you can proceed.
Good evening, everyone. Yeah, I hope you can hear clearly. I appreciate all of you for joining in at this time and also for keeping on with the sessions. I'm sure we are learning and we are actually heading towards the last sessions for this time, and we hope we'll make use of it as we advance our knowledge in analyzing data. So I welcome you all for today's session, and let's make it interactive. Make use of our trainer because he's here to help us understand more. Thank you so much.
Right. So we are going to go direct. Thank you so much, Samuel, for that opening remarks. I hope the rest of the team will be able to join. I'm told today being on a Saturday, majority are engaged in various activities, but I know even this matters a lot. So let me hope that they will be able to join so that we can start our training together. Now, we are going to start with a recap on what we covered during our previous training session. Today, we don't have much to do on the regression because we had already looked at the assumptions of regression. That's the linear regression or linear equation, if I may say, in a layman language. So today we will be looking at the single linear regression and multiple linear regression as well. Good, we go through just in the next few minutes, we just go through the last bit that we were able to cover under the regression analysis. So we looked at the introduction and the course objectives, and then from there we looked at the regression in details, where we say that regression is a statistical tool to examine degree or influence between the independent and dependent variables. We said again, it helps us to predict the outcome, analyze, and be able to quantify the strength and nature of relationship again between the standard variables. From there, we looked at our slideshow. Right. So from there, we looked at core assumptions of regression, where we say these assumptions matters a lot and they don't need to be violated. So you need to observe them if you want to proceed with the regression or some other inferential statistics. So that's the reason why we hand a descriptive and exploratory data analysis so that we can be able to derive some patterns and be able to confirm some of the assumptions like histogram. We did histogram, scatter plot, which you have seen also key outcome or output in terms of or in this area of assumptions. So we send violating the assumptions will result to biasness. That's the output biasness, and also inconsistent coefficient estimates, as well as the significance values, where the significance values matters a lot, because those are the p-values that we need to compare with the actual alpha value, which might be 0.05 or 0.1 if stated, or maybe the clients or someone maybe dictates that you need to use a confidence interval of 90 or 95. We send to get a alpha value, you just minus 1 minus confidence interval, whether it's at 90% or at 95%, so that you can get the alpha. And those alpha we need to compare with the p-value, which is the calculated value, and we need to compare so that we can make a decision. Now, from there, we looked at some of the assumptions. One, we say linearity. So that means there shouldn't be, or there must be, a linear relationship between the independents, which we call the predictor variables, and the dependent variables. We talked about the normality, and we said the data should be normally distributed so that we can again be able to confirm, because those are some kind of diagrams. Actually, those are like diagrams. Because when you use histogram, you use a scatter plot, all those you can be able to confirm. Then from there, we looked at homoscedasticity, where we say these are constant variance, and it's need to be maintained across all the analysis or all the steps. Then we said again there must be no multicollinearity between the independent variables. So there shouldn't be no high multicollinearity between the independent variable. Otherwise, if there is a multicollinearity, then we may not have the expected result. In short, we may not be able to have the expected result. So again, we looked at you don't need to have autocorrelation. There should be no autocorrelation, and we said these will be covered under the time series, where we have the advanced module on that, and I believe we won't be able to cover more when we'll be addressing that module. So we broke down into every assumption, and these are the ways on how you can assess or you can test the linearity of between predictor and the dependent variable. We say in terms of diagram, you can use scatter plot. This is also, we call these type of techniques, we call them data visualization. So remember, when we are doing the data exploratory data at the scatter plot, and we send if the data, we give even an example here. We send by look of the data here, as you can see, if the data is progressively, as you can see here, one variable increases, the other increases, then it will form a positive linear association or linear relationship. But in case one variable goes up and the other one goes down, so these we call that we have a negative linear association. These two demonstrate nonlinear association, where you will be able to see the data distributed sparsely, no pattern. You can't even derive a pattern, and even if you can derive a pattern like this one curved, you can't identify what kind of a pattern is this. So anytime we are looking at the scatter plot, we try to draw a line of it's called goodness line of fit. So we try to generate that line and see whether the data points are distributed within that line. Now from there, we looked at the normality, where we said we have the again you can access through the histogram, and also you can the live QQ plot, PP plot, which again you can be able to do on the descriptive even before you proceed to regression to inferential statistics, or then you can make a decision by the pattern of those the kind of diagrams that you might that you will be able to see. Alternatively, we said you can test it statistically, where you can use Shapiro-Wilk test, and you remember all the way on how to make a decision. I hope you remember that. Now, these are good example on how normally, is it normally? Yes, normally distributed data looks like. As you can see on the histogram, for the normal distributed data, it should form a bell shaped. As you can see, a curve, that's a bell shape. So this means the data is normally distributed. But comparing these other histogram here, there is no normal distribution of the data. This curve is lagged. You can see the drawing. So this confirms that this diagram are not shows that the data is not normally distributed. Then from there we looked at these are the QQ and PP curve. And both you can generate, they look almost similar, the QQ and PP curve. Now for the normal distributed distributed data, all the data point will be within this line of goodness fit, as you can see here. But if the line the data points looks like this or this diagram, you can be able to see this one represent a data that is not normally distributed. Next, we looked at the homoscedasticity. And for this one, again, we said you can just do a diagram as well. But you can do a test using a statistical test called Levene, which we did. And I believe you remember the procedure on how to do that. The procedure to do or to conduct a Levene test, this is the procedure. You just click analyze, you compare means, you click compare means, and then you proceed to one way and over. From there, you just click reset, or if recommended or there is something else that you have already changed, maybe you can just click reset. From there, you move to independent variable, you click continuous variable, you list it on the box, and then from there, you move the independent variable. Remember here, when you are looking at the assumptions, most of them we look at the relationship between the dependent and independent. But for the multicollinearity, we look at the independent variables. We check on the relationship between the independent variables. Now, from there, remember the factor box. Always the factor box represents the independent variables. So whenever you see a factor, that means you need to handle independent variables. Then from there, you click option, you click check, and then you proceed to checkbox. You click continue, click OK, and then you can just check on the Levene tests result, and you'll be able to make a decision as well. Now, from there, we looked at multicollinearity. We said this looks at on determine the effect, the relationship effect between the predictor variables, or the degree of correlation between the predictor variables. To do that, you just go to analyze, of which we said you can use a cross tabulation, or even you can use the Pearson correlation to check or to confirm first the degree of relationship between the 2 or 3 variables before you proceed to other analysis. Remember, for the cross tabulation, regardless we say this is for categorical data, we can also use it for continuous variables, because our main aim is to just to observe the relationship. We want to know the relationship, whether it's a weak negative, is it a weak, is it a strong negative, is it a weak positive, or is it a strong positive? If it is a positive relationship, then you should think otherwise. Then data might not give you what you expected. So you need to think otherwise. But now, because we are looking at the regression, we are going to do all this at once. And yes, for the multicollinearity, you can use the VIF factor, and also that's the variance inflation factor. And we say if the VIF factor falls between, actually it should be between 1 and 10, and you can see if greater than 10, then there is a serious multicollinearity, but between 5 or below 5, then that should not be a sum that should bother you. There is no high promote collinearity between the independent variables. Then from there, today I want us to look at types of regression analysis. We'll be able to do some recap maybe for the practical part as well. But for now, I want us to proceed. Today, we don't have much actually to address, since we'll be looking at the simple linear regression and multiple regression analysis, which is an extension of a simple linear regression. But we are going to learn some concept on the simple, which applies to the linear regression as well. Now, why is simple linear regression is important? We say number one is to check on the degree of inference. Remember the difference between the correlation, the Pearson correlation, and the regression. The Pearson correlation, we say this looks at the degree of relationship. But on this other hand, on regression, this checks the degree of inference. And we put and differentiation, a clear differentiation between the two, so that you can be able to understand when we talk about the degree of relationship and we talk about the degree of inference, what are we looking at? But I believe we can be able to do again some analysis so that we can be able to understand maybe or remind ourselves some of the concept. Now, for the simple regression, again, these are a statistical method to model the relationship between two variables, and mostly to check on the degree of inference. That's the reason why, if you remember, actually I have an equation here. This is an equation where we have y is equals to, this is now the c. This is c plus mx, if I may say, and then plus error term. It's just the disorganization of the equation, but this that's how it's interpreted. Now, as you look here, I think I've just given even the interpretation on which represent which. Sorry for that. Now we have y represent the dependent variable, and then we have the x independent variable. So the B1 here represents the x gradient. And this means if we want to interpret the B1, this we explain, or maybe we interpret this way. In terms of, remember we are interpreting in terms of x and y. So if 1 unit of x, or if maybe the equation is B0 minus, if it is a minus, then it means now one additional 1 unit of x then reduces y by the figure B1. If it is positive, it means 1 unit of x increases as well, y increases by B1 there. But I think we will be able to explain that better so that again we can understand. Now, then B0 is the constant interception point. Remember what we call the interception point, where x and y intersects with all other variables being constant or kept constant. So that's what we call the interception point or the gradient. Now, B1 I've said is the slope or the gradient of x. So we explain, as you can see there, we are saying this is how much y changes for each unit change in x. So if there is additional 1 unit in x, what's the inference on the other end of y? So that's the reason why we are talking about the degree of inference. And then on the other end of correlation, remember the scale that we use, -1, 0.5, 0, -1, 0.5 to 1 there. So we range our relationship there. It might be either negative weak, it might be negative strong, or it might be weak positive or strong positive as well. But we are going to do that so that we can understand better. Now, well, what's the main goal of a regression? Number one, we said is to predict. So although we will have more advanced regression modules, or we will cover some other section on how to predict outcomes, regression is one of the best I know, and so many researchers use regression for prediction, because you can use it to predict today, tomorrow. if you can do or collecting data maybe for a period of time, you generate maybe a simple regression model or maybe multiple regression model depending on data in different times. Then you can be able to predict maybe after 2 years or 3 years what will be the outcome as well. Again, number 2 main goal is to examine the strength and direction of the linear relationship. Yes, we can also determine if it's a negative, that means that if the gradient is negative, it means that one unit of the dependent y decreases. If it's negative, it decreases. The gradient, if the gradient is negative, it decreases. If the gradient is positive, then y increases. That's the reason why we are talking about and the direction. Now, again, we can use the regression to test hypothesis. That's the degree of association between, or maybe testing or confirming a claim that we might have. Now, the procedure is go to analyze regression, linear, and then from there you can go ahead and hand your dependent and the independent variables to some of the key areas, right-hand areas. Now, after analysis, what do you expect? After regression analysis, what do you expect? You expect a model summary. We will discuss that model summary, which provides the overall performance of the regression model. So we are going to see that how it works. Then we have the collinearity diagnostics. Sometimes you can generate, that's for statistical test. We are saying that's the multicollinearity. You can use the VIF factor to confirm the multicollinearity. But I remember the question that Samuel raised some time back, and I was able to address during our last session. I said you don't need to go to regression so that you can confirm the assumptions. You can just confirm some of the assumptions while you are doing the exploratory before even you decide on which direction to take. Is it inferential or non-inferential? Now, from there, we have the ANOVA. We have the ANOVA table as well. So the ANOVA table tests or predicts or confirm the model significant. So we are going to see that as well, whether so that we can know whether the model is really reliable or not. Because if there are some insignificant variables, it means the model is not reliable. Then we will look again, another table that will be generated is the coefficient tables table. Those are the regression gradients. We have the interception point, we have the gradient per the variable, we have maybe variable 1, variable 2, variable 3. So we will have that at the end. And then from there, for the mode regression, sorry about that. For the mode regression, it's just a repetition. What you're going to do is to add more independent variable. For the simple, for the simple regression, we just need to have one dependent, one independent. And then for the mode regression, we will have one independent and multiple one dependent and multiple independent variables. So now I want us to do a regression, but before we do that, I know I've said we are going to do a recap, the practical part of it for the assumption, and then from there we can combine with the regression. For this, we can maybe as we summarize, because we're going to also see how we can interpret or how can we now present these findings now from SPSS output to hand, and how you can format those findings as well. Now, allow me to have one of the data. I think I've shared several data with you guys, but I think I can just open one of the data, existing data, so that we can just use it for practice. Let me just open. Okay, let me just first open my SPSS first. A minute. so that we can proceed. I don't know why my SPSS is taking long. But just okay. You can see it as respondent. So I'm going to import data here. Just going to open and then click data. So you can export any of the data that you have. So I'm going to use Excel. Unfortunately, this gives me more of a string, variable type. So let me just try to find another data. It will allow me to use data that's not, it's not related to your area of speciality for learning purpose. So you can allow me just to use any other data. Or let me try to get maybe other data and see whether it can work. My team will allow me to use another data. Sorry for that. You will allow me to use another data. Okay, you'd allow me to use this data so that we can be able to understand the concept of the assumptions and as well as the regression. That's a simple and multiple regression analysis. Now, what you're going to do, as you can see here, during our last class, I talked about having a data with a Likert scale. Now, as you can see here, the data I have, it has a Likert scale. Yes, I have some other variables like these ones, and I can as well do the analysis, but I wanted to concentrate on these with the regression analysis here. I mean, the Likert scale. You can see V1, V2, V3, V4, V5, V6, V7. And then again, I have S1, S2, S3. So I assume all these represent one variable. This is like having a table with the statement, and then based on one variable, and then people say, maybe checking on the box to either disagree or agree. That's giving their responses in terms of the statements, either agree, disagree, neutral, and so on. Now, in that case, when you do the data entry, of course, you need to have each statement represent variable. However, you can't go ahead and do some analysis like inferential or any other. What you need to do is to compute a variable. You need to compute a variable that will represent all those. Right. So for now, what you're going to do, I can see I have, let me just identify the variables. We have V1. So we are going to compute. Yes, Samuel?
Excuse, which slide are you presenting on the screen?
You can see my screen.
I think it's still on the previous one.
Okay, let me stop sharing then and share again. Sorry for that.
Okay.
Now, I believe you can see the data now. Maybe confirm, you can see the data.
Yes, we can see.
Okay, sorry for that. Now, I was talking about those variables here, and I think I explained, or maybe let me just go back so that I can explain better. Allow me to use a Word document so that I can explain on the Likert scale so that you don't get lost along the way. Maybe in the future, you may decide to have a Likert scale statement where now you request you, those we call them closed-ended questions. That's the reason why we have closed-ended and open-ended questions. For that reason, it is very important to know how to structure, again, statements using a Likert scale, because at some point you may need to collect maybe more data on one variable. So I'm going to use one document to explain that so that we can be on the same page. Now, let's say, for instance, we are collecting data on on blood pressure. And now on this blood pressure, of course, you need to have some statements. And we need to have a table first. Maybe you can request your participants to indicate. Please indicate. The degree of agreement. Please, or states. Please states all check. Let me just, I'm trying to find the best one to use. I'm just trying to find the best ones to use. Let me just use the one indicate. Please indicate the degree of agreement for the, please indicate the degree of agreement with the following statements on blood pressure. And then maybe you can give your scale. Your Likert scale is 1 represents strongly disagree. 2 represents disagree. 3 represents neutral or not sure. And then 4 represents angry. And then 5 represents strongly angry. This is like a key just to help to understand what are these what's the Likert scale, what's the kind of a Likert scale that is used in this questionnaire. Now from there you need to give so you need to have a table. You need to have a table. Insert a table. So you click insert a table. Then you can have maybe a column of 6 so that you can also have the statements. And also you can have maybe 6 by 6 as well. Remember, these will be the statements. Statements. And from here you have strongly, or you can even just have 1 because already you have written there what they represent: 1, 2, 3, 4, 5, so that you can have enough space for the statements. So you can have such kind of a table. I'm just showing you so that in case when you want to collect data in a Likert scale, you need to come up with and not necessarily you have a table, by the way. It's not necessarily you have a table. If you can only repeat the questions and also the Likert scale that has been used, well and good. You can have statement 1, 2, 3, 4, 5 in not in a table but in a wording format, and then you can also indicate the scale. It can also serve the purpose. Now from there, on your first statement, maybe we are collecting data on what's the effect on blood pressure. Allow me to find some statements, just few statements. So we need to have the statements so that we can be able to, of course, to have them when we will be doing the coding. So let me say my first statement is I'm blood pressure. I'm jamming, or I'm just having I'm collecting data on effect on blood pressure. So my first statement is that I'm blood pressure negatively negatively affects my daily physical activities. That's the statement number one. Statement number two, I frequently feel fatigued due to fluctuations in my blood pressure level. In my blood pressure. And then you have statement 3 as well. Maybe I am aware of how my diet and lifestyle choices influences my blood pressure levels. So those are the statements you have. You can have more statements. Maybe you can have up to statement 10. So when your participant lean these statements, they always respond here by checking. As he or she can indicate whether he or she strongly agree that high blood pressure negatively affects his or her daily physical activity. He or she again, she can either agree or disagree that she frequently feel fatigue due to fluctuation in blood pressure as well. So they can just agree or disagree, or maybe not sure any of the kind. Now, when you do the data coding, remember all these statements collecting data on blood pressure. Now, for you to be able to compute or to proceed with the inferential statistics like correlation, like Pearson correlation, while you have this kind of data, you need to compute one variable that will represent all these statements, like calculating the mean of all these data collected, so that you can have a representative of all the variable of all the statements here. We call them items, of all these items. So allow me now to go to the data. I believe that's well understood. So that one will be a bit easier for you now to understand what we are talking about having V1. V1, I can call it statement 1, statement 2, statement 3, statement 4, statement 5, and the rest. Now, I want to give him 5 variables, 5 variables that influence blood pressure. I want to use the last one as the blood pressure. So for this one, I can call it, so I need to go to, so V1 or V variable represents, which one? Blood pressure is influenced by diet. I think so. So I can have now my V representing diet as a variable. Then from there, I have another variable here, S1. So S again, I can also have it representing what? What are the causes blood pressure? Stress level. So I can call it now S, representing stress level. Then I can check on another variable here. I have S, I have J. I have J. I have V, S, and J. Yes, I have J. So J to represent the number what? We have stress level, diet. I can call it a trauma. I think trauma and stress are two different, although trauma causes stress or depression. Anyway, we can have trauma as well. So trauma, I think, can cause also blood pressure at some point, I think. So we can have trauma representing J. And then we have B, have K as well. We have B, we have K, and then we have M. Right. I want to see whether there are some other variables because we are just trying to find out. All right. So the last one is M. So I'm just going to indicate M now to be our brand pressure. Brand pressure. Now we have B and K. I want you to give me another variable that represents or some that causes brand pressure. I think even cholesterol level or cholesterol. Cholesterol to represent B. So here, our B here, this B will be cholesterol. Now K will represent what? Even drug type. Can weather or climate cause I think even climate change I think can cause blood pressure. Climate change. So we have K as a climate change. We are just trying to find out these variables so that we can be able to analyze or to get our regression. So allow me now on the variable view, because we are going to compute, allow me to narrate this. We are going to compute our new variable with respect to what I've indicated. Then I go back to my data view. Now we start with the first variable, which is V, and we call it diet. So we are going to compute a variable V now. That's the diet. We are going to compute a variable diets, item V1, V2, V3, V4, up to V7. Now I'm just going to click compute, transform, sorry, and then I click compute. From compute button, we have the target variable. So I'm going to write here diet. I can just write diet. And then from the function group, I need to select which function group I'm going to use. We are going to calculate the mean, so we are going to use statistical. We are going to use mean. That means we are going to use a statistical here. Yes, we are going to use statistical. Yes, this is what we're going to use. And the function and special variable, we just check on mean. We check on mean, and then from there, I just use this button here so that I can have some numeric expression. I just click this button, and then from there now I can select my items now. Let me call them items. So for the first one here, I have I will have V1. V1 is this one here. I consider myself a frequent online buyer. Don't bother about the description. Let's mind about the items we have. V1. I'm just going to click V1, comma. You use commas to separate the items. V3, V4, V5, V6, V7. We have up to V7. From there now we will have S1. Now after that, I just click OK. And when I click OK, on the output view, I will be able to see this kind of information. I will be able to see that I have successfully computed diet variable with the statistical mean. I've used mean on the statistical so that, and I have selected item V1 to V7, which are the items or the statements under the diet. Now from there, I go back again to the next one, which is now the stress level represented with the variable S. So I'm going to click transform again, compute. And then here now I'm going to delete the item V1 to V7. And here on the target group, I don't need to repeat selecting statistical, going all the way selecting mean. So I can just iterate here. We have seen that the next one is the stress level. And remember, you can't connect two ones without underscore. Yeah, so you need to use underscore. And then from there, I'm going to select now from S1, S2, S3, S4, S5, S6, S7, S8. I have up to S8. I click again compute. So I believe you already know that procedure. So there is no need to just to keep on repeating. So let me just proceed the rest, but I think you can follow through so that we can compute these variables together. So next we are computing trauma, and then from there we can relate the items. S1, we start with now the J. We look for J1. Yes, we have J1, J2, J3, J4, J5, J6, J7, J8. I think that's the last one. Yes, J8 is the last one. And then you click OK. You have already computed another variable called trauma. Then we compute the next one, which is now B. B is the cholesterol. We have seen cholesterol. And this one will start from B1. We will have this one from B1. We have B1, B2, B3, B4, B5, B6, B7, and I can see we have B8. I'm not sure if we have B9. Yes, we have B9, but I'm not sure if we have, yes, that's up to B9. You click OK as well. The next one we are computing is climate change, which is represented by K. We type climate change. And then as well, we use from K1. We start from K1. K1, K2, K3, K4, up to K7. Again, you click OK. So finally, we compute the last one, which is now our dependent variable, which is blood pressure. So we are going to type blood pressure. And then we start from, this is M now. So we'll have M1. M1, M1, M2, M3, M4, and M5. Just click OK. Now, after that, you will be able to see your data. You will be able to see now there are some additional variables. On your data view, you'll be able to see these additional variables at the end here. You can see now the computed variable. You can see you have trauma, stress, diet, stress level, trauma, cholesterol, we have climate change, and then we have blood pressure. What we are going to do next now, we can reduce this one. As you can see, we have Desmos, so we can go to the variable view and reduce the Desmos to 0. Reduce Desmos to 0. You need to reduce all these Desmos to 0. Now, from there, what we are going to do now is we can first start with a simple regression. We can do a simple regression. So we are going to click on Analyze. We are going to click on Analyze. And then proceed to regression analysis. So you just click Analyze button, then proceed to regression, then proceed to linear. Here, you proceed to linear. We just proceed to linear. Now, as you click on the linear, you can see there are some options on the dependent, and then we have the options on independent. So for this one, we are going to select our dependent variable. We have blood pressure. So we just select blood pressure on the dependent variable. And then we have all these other, which represent the items on all those variables. We just click them to have them on the index. Now from them, before you proceed, you need to check on the statistics. So on the statistics, we will have model fitness. That's the reason why we have the ANOVA and also the model summary. From there, we can have the collinearity, where now we will have the VIF factor and the coefficient as well. We can check on collinearity. Now, these others we will be able to cover during other advanced modules. In other advanced modules, that's the Dabin, Watson, and the rest, because there is a lot. You have realized we are touching one-on-one, slowly by slowly, and I know we'll be able to get to the endpoint. Now, on the plots, the diagram, the scatter plot, we need the PP curve, we need the histogram diagram. This one we use the residuals, and we need to select this one. So for the predictant, we use Zend on the x-axis, and then on the residual, we just click here to hand them on y-axis. Remember we talked about the residuals and also having the normal data. You remember that. Now from here we can have the normal probability, and also we can have the histogram if you want to. It's very good. If you want to, you can generate them here. Now you click OK, and on the save option, let's see whether there is something we can select. Here there is nothing, so we can cancel. Now this one, now we select the confidence interval or the alpha value. If the confidence interval is 95%, our alpha value will be 0.05. If now the confidence interval is 90%, our alpha value, which is the significance level, will be 0.01, will be 0.1, actually 0.1. Now you change if it's indicated, but if it's not indicated, you just proceed 0.05, and then you click OK, continue. Now from there, you just click OK to get the outcome. So allow me to stop sharing. For this one, I've just used a multiple regression. Sorry, guys. But anyway, we say multiple regression is an extension of a simple regression. That means you have one independent and one independent. One independent and one dependent. Now, let me share the output. Let me share these outputs so that you can be able to see together. Now, you can see here we have the model summary. So the model summary gives you a summation, just as the one depicts summary. It gives you a summarized inference factor or value for all the variables, independent variables summed up. That's the reason why we are saying that the degree of variation from the independent variable to the dependent variable. Now, in this case, we look at the R. We look at the R value. Don't look at the R square. Just look at the R value. So here you can see we have the R is equals to 0.406. If you multiply this by 100, because we want to discuss in percentage, then you can see that the 40% on blood pressure are determined by the variables you have selected. That's stress level, trauma, cholesterol, and climate change. That means there are some other factors. There are some other factors that also determine, or not included in the model, that determine the blood pressure. That's what it means. So the 50.4, I think 59.4. The 59.4 are determined by other factors. That's the effect on blood pressure. The 54 are determined by other factors. Now, on the ANOVA, we look at the significance value. We are saying that the model is significant. As you can see, the alpha, not the p-value is 0.0. That means the model is significant. The model is significant. Now, from there, we look at the coefficient of the regression. We have the coefficient of regression together with the collinearity statistics. And remember, where we're talking about the VIF factor, you can see our VIF factor are within a range of 1 to 5. That means we don't have a high collinearity between the independent variables. That's diet, stress, trauma, cholesterol, and climate change. Now, on the degree of influence, now where we looked at the coefficient values of the regression, we look at these unstandardized coefficient in B column. This is where we look at this column. We look at this column here. I just want to highlight. We look at this column here. That's the unstandardized coefficient B values. This is where we look at. Now, if you remember the equation y is equals to mx plus c, you can be able to even to explain or even to substitute the regression. Now we have the constant value, which is again the intercept when all the variables or when all other factors are kept constant. And here it means that y on blood pressure will mean a 3.61 if all these other variables are kept constant. Now, if diet is taken into consideration now as one of the key factors that influences blood pressure, it means that if 1 unit of diet, or if you improve on your diet, it means that the blood pressure will increase. It shouldn't be negative anyway. It's only that I'm just using this data for demonstration. It's not the real data, just substituted somewhere. So don't take the outcome here seriously because it can't be. You can't improve on diet and then you get blood pressure going high. No, sometimes you are told to eat fruits and those improve your immune and all that. Now, so that means that 1 unit of diet, increase in 1 unit of diet increases the blood pressure by 0.79 or this is 7.9% if I'm not wrong, 7.9%. Now, on this other end, on the stress level, it means that 1 unit or an increase in stress level will result to increase in blood pressure by 13.7%. Now, if trauma increases, then again, the blood pressure will increase by 7.1%. If cholesterol levels increases, then blood pressure again increases by 19.0%. If climate change, if there is a change in climate change, then the blood pressure will go down by 78.1%. I'm not sure of that, but I've said this is not the real data. I'm just using this for demonstration. Now, let's look at the significance level. Are they significant? I can only see this one here. I can only see the cholesterol, which is significant. The rest are non-significant. So that means they don't have much impact. Reason why on the model summary, you can see all those factors contributing less than that 50%. It shows that they don't have that much weight on the blood pressure. But anyway, it's because I'm using just the wrong data. I'm not using the real data. Otherwise, this could prove me wrong if I'm using another data, the collected data, the real collected data that represent all these variables we could have some better outcome on that. Now we are talking about the collinearity, and there is no need to go back here to determine or to talk about the collinearity here. What matters a lot is the VIF and the tolerance value. Now the rest you can be able to see on the diagram here. So can you tell, is this data normally distributed by look of this diagram? By use of this diagram, the histogram here, can you tell whether the data is normally distributed or not? Is the data normally distributed? Just tell me over the chat there. Tell me whether the data is normally distributed. Is it normally distributed or not? Or maybe we can look at some other knee, some other knee diagrams. Now you can still check on this one here. Check on this diagram here. Does this show an data a normal data distribution? The PP curve. Remember we talked about different the normal distribution should form a curve, but you can see this one is close. This one is close to a curve, but you can see there are some few. These we can call them outliers. Remember the word outlier? So we can see we have some outliers here. They are not many. We have only 1, 2, 3, 4. We have only 4 outlier. So I think this one we can confirm it. We can just confirm that this is a normal distribution, regardless of a few outlier, regardless of having a few outlier. And you can also confirm through these the PP curve. You can see the data points and distribution are distributed along the line of goodness fit. Now on the scatter plots, this one proves as long. This other one proves as long. You can see the data and sparsely distributed. You can see here some outliers, some points, some outliers. So this one, can you tell whether it's a linear, positive or negative? Actually, you can't tell. There is no pattern there, so you can't tell whether the data is normally distributed there with this one, with the scatter plot here. This one can prove that there is no data, there is no normal data distribution. That's the scatter plot. So what you need to do now for you to confirm, you can do a statistical test to confirm whether there is a linear relationship because we are testing the hypothesis, or I mean we are testing the assumptions. But through the VIF factor here, I can confirm the data is normally distributed. It's only that some might have some outliers and all that. So, but have said you can just go ahead. You can just go ahead and do some more research, do some more analysis about that. Thank you, Sarah, for that. Natumai the rest can be able to see as well. Now, this is what we call now the mode regression. If you're doing a simple regression, you can just only have one independent and one dependent variable, one independent and one independent variable, and that's all. So I believe now up to that point, you are now, I can confirm that you have some basic and also some intermediate skills for you that can enable you to perform various data analysis using SPSS. Unless you read me down, but for now I can prove or I can confirm that I've given you the necessary skills for you to start data analysis with SPSS before we engage on those other modules. So for now, I would like to take queries if there is any. If there is any query, you can ask. If there is any query, you can ask before we end our today's session and we close our cohort 1 SPSS bootcamp training there. So anyone with the query, anyone with a concern? Yes, so I want us to stop there so that we can also be able to, there are so many other modules I know we are going to expound more. Even on the regression, there are some others we are going to look at including time series, and some others. Along linear as well. We are going to look at that when we'll be venturing on, or when we'll be covering other modules, so that at the end we can be now competent or experts using expert in data analysis using SPSS. Right, I'm waiting to hear if there is any query, any concern as well. I would like to hear from you guys, because this is our last day. But as I said, maybe we will have same cohort, one day, one time, because we'll have another cohort now. For those who have yet to attend the training, we have another cohort 2. And then maybe during our cohort 3, because I'm sure you will be the cohort 3 when we'll be covering some other modules. I don't know the plan by the executive, but I'm yet to know. It is well. If they decide we proceed well, I am ready to go ahead and make sure we cover the rest of the modules. So for now, I'm waiting for your feedback, comments. I'm waiting for your feedback and comments, so that I can hand over the session to Samuel to give his closing remarks. Welcome. Also invite one of you to play for us as we end our today, our actually cohort 1 bootcamp training. I hope you are doing your assignment as well. I hope you are doing your assignments. So far, so good. I'm going to upload the last assignment by Tuesday, so I'm expecting you to submit the due assignment. That's assignment 4. So that when I upload assignment 5, you're already done with assignment 4, so that you can be able to do the assignment 5. I will extend the assignment submission for those who are yet to do so because of 1 or 2 challenges here and there. I hope now you can go back and do the assignments, upload, and I'm going to open to keep the class assignment open for the next maybe 1 week from today. Even next week, the class will be open throughout the next week, actually, till Sunday next week. I will make sure the class is still, the submission are still open so that you can submit your assignment. I will be waiting to see your assignment, and so that the executive can be able now to decide where are we going to enjoy these milestones or these achievements of our data analytics or researchers in short. So I'll be waiting for that day so that also we can celebrate together these achievements as we aim to venture more in this research and specifically data analysis. I was a privilege today to meet Zadok and Tabi, and I was so grateful to interact to hear from them. They are really passionate and interested to venture more in research, know more about data analytics, and I believe guys you are choosing the right path. Always make sure you get or have a diverse skills, not only in your area of specialty, because I know you are all in either pharmaceutical or in health, yes, in we have the pharmaceutical and which other health, I think. So I believe it's good to have more diverse skills. Research is important in medical area. Research is important, data analysis is important. So make sure you venture well, and I believe we won't be able to have competent researchers and data analysts, scientists, data scientists. All right, so I was just waiting for your comment. I can see Sarah and Nicole comments. I can see Sarah Mesema. For me, I am grateful this opportunity was created, and I have been gaining a lot since I started than I expected. Thank you for your time and commitment into guiding us through this SPSS training. That's from Sarah. Thank you so much, Sarah. From Nicole, she's saying that yes, thank you so much, sir. And I'm grateful for that. The rest, where are your feedback? Where are your feedback? I want to hear from you. I want to hear from you. You have done it. If I didn't do well, please even negative comment allowed for improvement. Even negative comment allowed. for improvements. And I would like to hear from you. I know you'll give feedback to the executive and also to our key partners, the Immobilis and other key partners involved. But it's good to hear first so that I know I did a good job, even as we continue our aim to venture more. From Zadok, we truly appreciate your dedication, support, and the knowledge you have shared with us. Thank you thank you, and hoping to meet you in module 3. All right, I'm so grateful, Zadok, and it was my pleasure to meet you as well. All right, so I think now I can welcome Samuel as we wait for other comment, maybe, so that we can have our closing remarks. Can see from Onesimus, I'm thankful for sacrificing quality time to train us. I learned a lot and enjoyed. Thank you, Onesimus, for that supportive feedback as well. So, Samuel, you're welcome. You can give your closing remarks as we conclude our Code 1 SPSS bootcamp training to the end. And also, you can invite one of you to pray for us as we close our session today. Thank you. We will keep our conversation over the WhatsApp. In case of any concern, any query, we will be able to reach out through or to communicate through the WhatsApp. Thank you and welcome, Samuel. And thank you, Tabi. I can see your comments. The session was well explained. Thank you so much for that feedback. Prudence, this was very informative, and thank you for training us. I'm so much grateful for the feedback as well. So now allow me to invite Samuel to give us a closing remarks as we end our Court 1 SPSS bootcamp to the end.
Wow, yeah, it's been an amazing session from the first week up to now. We've been really learning a lot from you, Mr. Zablon, and we are really grateful. So at this time, I would like to ask the members, please let's do some reactions. You can use emojis or any kind of emoji, yeah, to appreciate our trainer. Maybe you can do like this, you can clap, yeah, just to appreciate Mr. Zablon for his time. Yeah, you remember he told us he has a family, so he has to take care of the family, has other engagements to do. It was really amazing to learn from you. Yeah, thank you so much for the reactions. Yeah, it's been really a good journey working with you. And personally, it's like you were like supporting us because me, I tried to study it on my own. I took an online course, but unfortunately, I didn't finish it. But with your assistance as well as the team, yeah, I've been able to work with you and try to do the assignments you've been giving us, and I can really see the improvement. So I thank you so much for that, for being with us. I would also like to request if all of us can put on our videos and take like a picture, since we might not get to meet very soon for this particular cohort. So if you don't mind, please kindly switch on your camera so that we can take like a screenshot. If you don't mind, please. Yeah, thank you so much for, you can put on your cameras. We've been all behind the cameras since week 1. At least once in a while. Let's put on the cameras. Okay, I think those are the people who are able to put on the camera. Any more people? Then we take a screenshot. Wow. You should smile now. Thank you so much. Yeah, I've taken the screenshot. Can put off the camera. It's okay. Yeah, it was good to have you all here, and I would like to encourage you as well to keep on practicing the exercises we've been given. We can repeat as more as we can so that we retain the information. Also, if you are able to like form maybe a simple question, you can form it and share it in the group for the members to fill in. Then you use that data to try and uh, put into practice what you have been learning. You can do just simple descriptive statistics or even inferential statistics as I've been learning. I'm sure if we try to do that, we'll be able to retain the information more as compared to if we stop from here. And also, I'm hoping that, we'll keep on improving our skills as we are told we have some more concepts to cover. So once we put the call, I'm looking forward to seeing all of you attending the sessions. That was it from me. I'm going to welcome any volunteer to play for us as we close the session. Any volunteer kindly to play for us? Any volunteer to play for us? The dog.
Okay, we pray. Almighty God, we thank you for you being walking with us. Thank you for you guided us throughout the whole session. Thank you for guiding us, Lord, in all that you also planned for our lives, be it academics, Lord. May you walk with us, may you guide us, may you forgive us our sins. And everything that we do, Lord, let them be with us, that draws us closer and closer unto you, Lord. Continue guiding even our tutor, our instructor. May you walk with him. May you guide him, may you give him more, may you grant him your knowledge, Lord, and strength, your wisdom, Lord, so that, Lord, he may also continue, Lord, mentoring many and many people, Lord. Father, Lord, may your glory be seen also in everything that you do each and every time. Continue guiding us, even as we prepare us for a second coming. For I do pray in Jesus' name, amen.
Thank you, or see you another time.
All right. Bye bye, guys. See you another time and wish you well. Remember to submit the assignments so that we can be able to award marks as well. And for those who are yet to do, please do so. Make sure you submit. I will mark and I will ensure that I mark all the assignment and award marks. Thank you. Keep safe till we meet again.